Entire ecosystems are collapsing. We are in the beginning of a mass extinction.
What is lithosphere? Lithosphere is the rigid outermost rocky shell of a terrestrial planet or natural satellite. On Earth, it is composed of the crust and the lithospheric mantle, the topmost portion of the upper mantle that behaves elastically on time, scales up to thousands of years or more. Lithosphere is the solid outer part of Earth. Lithosphere derived from the Greek words lithos, meaning stone, and spira, meaning globe or ball. Why is lithosphere important? The lithosphere provides our forests, grasslands, and is responsible for agriculture, human settlements, and is a rich source of minerals. Without the movement of tectonic plates, no mountain ranges and continents would have been formed on Earth. And if there's no lithosphere, there would be no resources like soil, minerals, and rocks, which are very useful for men. The majority of the resources that man requires are supplied by the lithosphere, so it is impossible to live without lithosphere.
Let's talk about the Earth's crust. Crust is the outer portion of the Earth, and is the upper rigid part of the lithosphere. Let's have an example. I have here an egg. The egg could be seen as a tiny model of the Earth. The thin shell represents the Earth's crust. The crust is made of varieties of solid rocks, the sedimentary, metamorphic, and igneous. It has an average density of 2.8 grams centimeter per cube, and its thickness ranges from 5 to 50 kilometers. The vase, which is defined by prominent seismic discontinuity, the Mohorovicic discontinuity, or MOHO. There are two kinds of crust. The thicker but less dense is continental crust, and the oceanic crust, which is relatively thinner but denser than the continental crust.
What is mantle? Let me explain something. The mantle is the most solid bulk of Earth's interior. The mantle lies between Earth's dense, superheated core and its thin outer layer. The crust and the mantle is about 2,900 kilometers thick and make up a whopping 80% of Earth's total volume.
The atmosphere is a crucial layer in the Earth mantle. Lying beneath the rigid lithosphere, its depth typically ranges between 80 to 200 kilometers or 50 to 124 miles beneath the Earth's surface. This region is characterized by its particularly molten ductile and weak nature, allowing for the slow movements of the Earth's tectonic plates. The atmosphere's unique properties are a result of an instant pressure and temperature condition within the Earth's interior, causing rocks to exhibit a semi-fluid behavior. The fluidity enables the lithospheric plates to move and drift atop the atmosphere. Such movement is responsible for various geological phenomena, including continental drift, the formation of mountain ranges, and the occurrence of volcanic activity. Although the atmosphere has a substantial impact on the Earth's geology, it's not a homogeneous layer and can vary in composition and behavior in different regions. At present, the instrumental in the process of plate tectonic, playing a significant role in the recycling of the earth crust and formation of new crust throughout the seafloor, is spreading and subduction zone. The atmosphere's flow properties are crucial for our understanding of the earth dynamics as they influence seismic activity, magma generation, and distribution of heat within the planet. Scientists study the atmosphere to gain insight into the fundamental process shaping the Earth's surface and its geological history. Example of atmosphere is influence is the movement of tectonic plates, such ongoing divergence of the North America and Eurasian plate along the mid-Atlantic ridges. In this instant, and semi-molten rocks in the atmosphere allow for gradual separation of two plates, leading to the formation of new oceanic crust and the subsequent widening of the Atlantic Ocean. Furthermore, the volcanic activity in Hawaii Island can be attributed to the interaction between the Pacific plate and the underlying hotspot as the Pacific plates move over the semi-fluid atmosphere. It creates a conduit for magma to rise throughout the Earth's crust, resulting in the formation of volcanic islands like Hawaii. This example highlights the crucial role played by a terrestrial in facilitating various geological processes, including the movements of tectonic plates, the formation of new crust, and the occurrence of volcanic activity.
The age of oceanic crust varies depending on its location. Oceanic crust is continually formed at mid-ocean ridges and eventually subduct back into the Earth mantle at subduction zone. On average, the age of oceanic crust is relatively young, with the oldest known oceanic crust being around 200 million years old. The majority of oceanic crust is much younger, typically less than 100 million years old.
The age of the continental crust varies significantly from place to place, ranging from as old as 4 billion years in some areas to as young as 2 million years in others. The oldest known rocks on Earth are found in western Greenland and have been dated to be over 3.8 billion years old. In general, the continental crust is older than the oceanic crust, which has an average age of around 260 million years. However, there are exceptions to this rule, such as in areas where oceanic crust has been subducted and recycled into the continental crust.
Density. When we say density, this is the dense of crust, and there is two types of crust, the continental crust and the oceanic crust. The continental crust is broadly granitic in composition and with a density of about 2.7 grams per cubic cm, and somewhat is lighter than the oceanic crust, which is basaltic in composition and has a density of about 2.9 to 3 grams per cubic cm. In other saying, the oceanic crust is denser than the continental crust.
Scientists use methods like seismic surveys and drilling to measure the thickness of the Earth crust. Continental crust, on the other hand, it is layer beneath our continent. It is much more thicker than oceanic crust, ranging from 22 kilometers in thickness. Oceanic crust is found beneath the oceans. It is thinner than continental crust, measuring approximately 5 to 10 kilometers in thickness.
Molten basalt lava has a low viscosity due to its relatively low silica content between 45% and 52%, resulting in rapidly moving flows that can spread over great area before cooling and solidifying. Flood basalts are thick sequence of many such flows that can cover hundreds of thousands of square kilometers and constitute the most voluminous of all volcanic formations. Basaltic magmas within Earth are thought to originate from the upper mantle. The chemistry of basalts thus provides clues to processes deep in Earth's interior. Molten basalt lava daw po ay mayroong mababang lagkit ng dahil sa mababang nilalaman ng silika nito, at nagreresulta sa mabilis sa paglipat po ng mga daloy ng lava na maaaring kumalat sa malalaking lugar bago pa ito lumamig at tumigas. At ang mga baha naman po ay mayroon siyang kapal na pagkasunod ng dami ng daloy na maaari rin pong sumaklaw sa daan-daang libong kilometro at bumuo ng pinakamalakas na pagbuo ng bulkan. Ang basaltic magmas naman po na nasa loob ng Earth, ito po ay ang pinaniniwalaan na nasa itaas ng mantle. Ang chemistry po ng mga basalts na ito ay nagbibigay po ng mga pahiwatig sa mga prosesong malalim sa loob ng Earth. Yun lamang po.
Granite is the most widespread of igneous rock underlying much of the continent crust. Granite is an intrusive igneous rock. Intrusive rock from molten material magma that flows, that solidifies under where magma cools slowly. Eventually, the overlying rocks are removed, exposing the granites. Granites usually have coarse texture. Individual minerals are visible without magnification because of the magma cools slowly underground, allowing larger crystal growth.
What is tectonic plates? Tectonic plates are gigantic pieces of the earth crust and uppermost mantle. They are made of oceanic crust and continental crust. What is plate tectonics? Plate tectonics is a scientific theory that explains how major landforms are created as a result of Earth's subterranean movements. The theory, which solidified in 1960s, transformed the Earth science by explaining many phenomena, including mountain buildings, events, volcanoes, and earthquakes. What is the difference between tectonic plate and plate tectonics? Tectonic plate is a gigantic pieces of the earth crust and uppermost mantle. And plate tectonics is a scientific theory that explains how major landforms are created as a result of Earth's subterranean movement.